Okay, now we're going to go over the very last section, and this is about the chain rule. This first part that we're going to look at is what we did in our pre-calc classes when we had a function inside a function. It's called a composite. So in these particular problems that I've got in example 1, f of x is equal to 2x squared minus 3, g of x is equal to 1 minus 2x. And they want us to find the composites. Now if you remember, this is when I've got a function inside another function. So using technically your order of operations, first thing you do is you always start on the inside, work your way out. So g of x, the equivalent expression to that is 1 minus 2x. Okay? Now this is telling me, due to functional notation, wherever I see x in f, I use parentheses and all and substitute that quantity, 1 minus 2x, in place of it. So this is what I'm looking at when I'm talking about a composite function, because I've got one function inside another. I could algebraically go ahead and clean this out a little bit more. I can FOIL this, distribute through, so this function can simplify to this. But if you'll remember, I started with two different functions, and one was placed in, it's substituted in for x in the other expression. Now this is f of g of x. The next example I've got is g of f of x. So first I'm going to go get f of x because that's on the inside. So that would be my 2x squared minus 3. Now, using parentheses and all, I'm going to substitute this in where I see x, which is right here. Distribute through the negative 2. Combine like terms. They're two different functions because I went two different directions to find them. But remember, this is a composite. Biggest thing here is you've got a function inside a function. And that's one of our bases for this particular rule that we're about to see. Now the word chain in the name chain rule comes from the fact that a function formed by a composition involves a chain of functions, that is a function of a function. Chain rule enables us to compute the derivative of a composite function in terms of the derivatives of the functions making up the composition. Usually you can see these, I won't say a mile off, but a pretty good distance off, in that just how they are, just the composition of them. So I will have a parentheses, I'll have a constant, it has to be a number, a constant in front of the parentheses. Inside the parentheses, more than a monomial, and we can let this be u, and then this exponent on the back, some power other than 1. So I've got f of x is equal to this quantity raised to the 6. So my constant in front of the parentheses is 1. This is definitely more than a monomial, and this is going to be my exponent, which is not 1. Now my rule. Now look at this. I've got to have a constant. I've got to have what I'm going to call u, and that's what is always on the inside of the parentheses, and my exponent. Now this sort of takes on the form of our very first derivatives that we did back in chapter 10.5. I'm going to go exponent times constant. I've got my variable, decrease power by 1. But now because this is the chain rule, and I have got to also account for the function on the inside, notice what happens right here. I get the derivative of what I have called u. So there's a couple of ways you could do this. You could write out this is u prime, and then put it back into the formula. There's a lot of different ways. So let me see what I did here. This is that example we had just a second ago. So I'm going to have my f prime. Okay. So I'm going to 6 times 1. I'm going to, if you'll notice, the u is rewritten. Decrease power by 1 times, and I usually call this the derivative of the inside, because if you'll notice, here's u, and u prime is the derivative of the inside. Now, if you have a monomial times a monomial, they will go ahead and multiply this. So I should have 36 times that quantity raised to the 5th. And that is my answer. So you see, I don't have to write this out 6 times. I don't have to do a ton of multiplication. I can use the chain rule, and boy, is it a whole lot faster. See, I've got some more examples. I've got this one. Now I did it 2 different ways. One way by chain rule, the other way is if I cubed it out. And that's what I was saying earlier about that other binomial raised to the 6th. Look at all this work. Now I know I can go get the derivative real quick here, but I'll do that in just a second. Let's try our chain rule. This is my u. My u prime would be 2. Remember where that goes. Again, this is a new formula. So when you need a formula, write it down until it sinks in. So let's go do f prime. So I'm going exponent times my constant, 3 times 1. Remember u, there is a rewrite. Decrease power by 1. Remember what I said u prime was? There it is. So I've got 3 times 1 times 2. So this should clean up to 6 times that quantity squared. So there it is. This one, f prime of x, would be 24x squared plus 24x plus 6. Okay, I'm going to factor out of 6. Then this will factor, because I wanted you to see that this is the exact same thing. This is so much faster. So again, let's look at that formula. I'm going to have a parentheses. You'll see it. You'll have that parentheses. You're going to have a constant. You're going to have an exponent. So I've got n times c, exponent times constant. That should sound familiar. The u is a repeat. It's brought right down. And then I decrease power by 1. Times, big dot. I've got to do the derivative of the inside because I'm doing chain rule. I've got links. Let's look at this next one. See a radical. I don't care what the problem is. You've got a radical you're going to have to rewrite. So this is going to be the quantity 9t plus 2 raised to, do you remember? Should be 2/3. There it is. Now it's in the correct form. My constant's 1. I've got this more than a monomial. I've got an exponent, so I'm going to go 2/3 times 1. I've got to rewrite this, decrease power by 1. That's sort of old. The new thing here is I've got to multiply by the derivative of the inside. So let's see what I've done. So 2/3 times 1. This piece is rewritten, decrease power by 1 times derivative of inside. Now if you go 2/3 times 1 is 2/3. 2/3 times 9, that should give you 6. Let's see what I've got so far. Okay, whoopsie. Cover that back up. Then this, the book allows you to do that. Do not change it back to radical form. I prefer myself exponents being positive. So let's see what I did. I moved it down, got the reciprocal, and that's my answer. So I'm going to have 6 parentheses, this raised to the, do you remember? Should be 1/2. Constant, stuff in parentheses, raised to exponent. I'm going to go 1/2 times 6. That'll give me a 3. I've got to rewrite, decrease power by 1 times big dot. Because it's after the big dot, we get the derivative of the inside. Let's see. Moved it too far. So 1/2 times 6. There's my n times c. Here's the rewrite. Subtract 1. Derivative of the inside. So 1/2 times 6, that would be 3. Let's see what else I've done. Couple of things. This gives me 3. This is still in the numerator. Look at each factor to see where it needs to go. The only one that needs to go denominator technically is this raised to the negative 1/2, because it really it needs to be positive. But like I said, if you clean it up and you've got 3 parentheses 2x minus 2 times that quantity to the negative 1/2, we can still use it. We'll still use it. I could factor out a 2. There's a lot of different answers I could take. Let me see. I did factor out a 2 here. There's my answer. So guys, when we get the derivative, there is a rule that is involved, but pretty much once you apply that rule, everything from right here where I'm at with my cursor going back and forth, this is pure algebra. That's all that is. Now, next part, I've got some extra practice. And this is with respect to the chain rule, whole bunch of them. And it just so happens on the next page, there are answers. So you need to play with these, and that will be the end of this chapter. So, talk to you later. Bye-bye.